So we had started talking about the software development lifecycle, and basically what we wanted to talk about is how it has been evolving over time in our industry. Our industry is a fairly young industry, and we're still trying to identify what is the best way that we can collaborate. Oftentimes, trying to borrow from other industries, see what works there, and can be adapted to our own. Taking into account the nature of our perspective, of our particular perspective, so we had mentioned that there were at least two sides to this, right? The our side, which we often refer to as the tech side, that we control what's the technology stack that we're going to use, the team members, the overall process of gathering the requirements and guiding the clients through the whole process. The clients don't know how to develop software. That's not their business. It's our business to develop software. So it's us who imposes or selects or promotes a particular methodology to build whatever that it is that presumably they need. Oftentimes includes trying to identify what it is that they need. The client instead, controls the cost, the functionality they think they want, and any other constraints such as time and how much money they're willing to invest in the endeavor. And it's all about how do we communicate amongst ourselves in the short term, but also in the long term, since teams come and go, people change teams, people quit, they have families, they have other lives. And it's a very messy world. How do we control the chaos? So how do we communicate so that we all understand the same thing? And again, mentioning that everything's in motion, everything it's a very chaotic environment. And how is it that we introduce some control over it? And again, a lot of this makes sense to talk about when we talk about large projects. When it's something that's something personal, it's mine, and me and my friend, just a couple of us on a startup. Maybe doesn't make sense to have any of this, heavyweight ways of controlling. But if you have, more than a couple, more than a dozen the folks that are starting to collaborate amongst each other, certainly, or trying to solve something that's fairly complex, then certainly you want to be able to find some methodology that would ensure some level of success, right? And we'd like to be able to know, how far are we? What is our progress towards that success? Also, that we mentioned that we are just one part of something larger, and that we have to understand that our particular role in the larger picture. It's often the case that as developers we find ourselves most comfortable just in front of a monitor and just typing away, but oftentimes it's useful to see how our particular participation fits within the larger scope of the company, of the project in general. So so it's all about identifying what is the best process that we can agree on to build a successful piece of software. We would love for that when we leave, when we're done, that folks look back at our process, at our product, and say that, yeah, what you wrote is reusable. I can. It's general enough. It's modular enough that I can. It's general enough that I can grab it and maybe reuse it here. It's understandable. It's self-explanatory, self-documenting. That it has all these good properties that are what make good software. Yeah, so the purpose, the overall purpose of software development is again, it's to manage, to lead a process to successful completion. That we consider all the various risks that are involved, and that we identify them early on so that we can try to mitigate those risks and see what their impact might be. So there might be things that are very risky but have a very low impact, right? Or things that are low risk, but if they do happen, would have a huge impact. So all these, identifying all these things are the purpose of the SDLC, and identifying what measures we could do to resolve or mitigate those risks. Managing, again, a team of human beings that we're messy people, right? And with our own biases. Let's see. So the various steps or parts of the SDLC has these very high level phases. First, making sure that we can even do this. Can we build this? Within the particular constraints. Given your budget, given your cost, given the how much you're willing to spend on this, and how much time we have. Is it even feasible? Do we even have the technology to do that? So it's usually it would start with a feasibility study, right? Then we would start gathering what is it that you want me to build, right? So and specify in a contract or in a commitment what is it that we're going to be building and specifying as much as we can, understanding that a lot of it we don't understand yet, right? That we might understand it as we go along, as we start building it. It is sure to be that we will identify new things that we didn't know, and only then we will have enough domain knowledge to be able to start understanding it and specifying it. So it's sometimes might be futile to try to specify something that we don't understand yet, right? So that's a little bit the difference on how the processes have evolved over time. With the legacy, the more established, historically established processes try to specify everything at the beginning, even though many things were yet unknown, that were not yet ready to be specified just yet. Then there's a part of architecture and design. Again. The processes, the various processes over time have evolved on how much and when architecture and design occurs. Again, in the legacy ways of processes, you would have a lot of architecture way at the beginning, where you have try to define the entire data model, try to define all the entire user interface up front. Even though we weren't sure that any of this was yet going to be needed. Oftentimes we would over-design things unnecessarily, and you would end up with tons of tables that were never used, or lots of tables with lots of nulls everywhere, right? Where you would have tables that would have 20 fields, of which we're only using 2. And so this is actually very, very common today, right? That things were over-engineered, thinking that this was going to be used in a particular way, and everybody from various from various parts of the organization, pulling their way on what features they wanted our systems to be, when later on, when it was actually put in practice and put in and deployed. Users that weren't actually using it the way they thought they were going to use it, right? So today, the newer processes consider doing architecture just enough, to architect and design enough to get started, enough to to have probably maybe the core functionality or the core business, and then as we progress and we put it out there for the users to use it, we can then get some feedback from the field, and then maybe steer the application one way or another with brand new feedback from real users. Obviously, then you would go into a development phase, a validation, and maintenance. So all the various methodologies, they all have these various core elements, right? They all have a feasibility, specification, architecture, design, development. It's just that we have just changed a little bit on how much of it and when, right? And so that to deal with the changes in the market, as as the business has changed over time with new paradigms in software development, as they change. When one of the big shifts in the software development world was when we introduced object-oriented technology, right, from procedural technology, and introducing these new ways of thinking about software development also had a big impact on the way we build things, right? And then later on in the .com bust, when we introduced service-oriented architectures and component architecture, things like that, right? That also had a big impact on how it is that we build software, and also your folks going from everybody carrying a mini computer on their pocket and texting all the time, and all the how the dissemination of information just got so ubiquitous. That also had a huge impact on the life cycle and how fast we want to be able to respond to changes in the requirements from our users, right? So anyway, so all the processes that we're going to look at, they all have these aspects. It's just in what quantity and how much of it we do it in what order. So early on we're all very optimistic. We have this honeymoon when the client and the software developers they promise each other all these commitments early on, but then the process becomes much less prettier. The reality is that it's very tumultuous, very unpredictable, especially for the management team that has to deal with all these changes. So early on, it was that we would have a very simplified view of software development. Just tell me what you want, and I would go and build something. I would bring it back to you, and we would just iterate over until the user was satisfied, which is a little bit of what has today. Extreme programming and some of these newer methodologies are somewhat coming back to some of these ideas that were already in place, half a century ago. So a lot of things that were old are starting to become new again, and a lot of the things that we are rediscovering and re-implementing, and all these feed into each other, trying to copy some of the good things about all these processes and try to reinvent ourselves. So some of the challenges of this this first very simplistic approach of code and fix is that there was no historical documentation on how things were done, or any formal way that you can be confident that what we were originally wanted to build was actually what we delivered, and there was no the teamworks were very fluid. There was no separation of concern, where everybody wore tons of hats. There was no specialization, and when you don't have specialization, you get very little efficiency, right? But a lot of the things that were in vogue, half a century ago, are starting to come back, right? As we try to break up large problems into smaller ones, and we go off into smaller groups, some of these same ideas are starting to come back. So back then, especially if these were larger projects, it was horrifying back then. Today, we're trying to say, okay, well, let's try and use those same ideas, but to tackle a large problem, let's break it up into some smaller pieces, and then we could perhaps use some of these iterative approaches that were in vogue back then. To deal with some of this madness, we kind of swung the other way around, right? So from no formality to very, very formal processes. Some of these were borrowed from many other industries, from from heavy industry, from the space industry, from all these military that had these huge projects, and taking a look at how they deal with these complex systems, so perhaps we can adapt some of these same techniques to the software world, and it became these what today we refer to as the waterfall model. That again, you had the feasibility, specification, and one of the problems is that we tried to predict a lot of things that were unknown just yet, that would become apparent later on as we are developing. Right, new questions come up, and we had to understand the domain a little better, and then we kind of start questioning what our original decisions early on. But it was somewhat rigid, that it didn't kind of allow the changing course. So today we borrow many of these ideas, they're the same particular structure, but we try to flatten a little bit so that we can have the user participate, all throughout these the end user participate, be an active participant of this process, so that they can better gauge what the progress is, and better help us steer it towards the right direction. Right. So it's typically we identify these waterfall process modeling as very heavyweight, or very hard to steer, very hard to change, and especially as the business world and the as our clients have become a little much more knowledgeable of what they want, and how they share information amongst each other. They change their minds very often. So we the way we need to develop today needs to be able to also keep up with the changes on the client's point of view. So waterfall again is often considered to not be able to adapt to changes quick enough. So we saw some of these processes, right, where you would have up front there would be a lot of communication, where we try to formally capture the various use cases and scenarios and the actors that would participate. We saw a lot of that in the requirements phase, so the requirements presentation we did on Tuesday. Once we had identified all these use cases, we would go into a planning phase and then try to predict how much time we would take to build certain things, right? And we would try to divvy it up into different lanes that didn't have any dependencies amongst each other. But those that had dependencies, we would schedule it that certain things need to be built first before we build certain other things. So certain things could be built in parallel. Certain things needed to be built in sequence. So planning was all mapping what kind of resources we had in manpower, and then mapping them against all the different tasks depending on the skill sets that we needed, and any of the constraints that we had either in time or cost. And then we would, once we identify the data that we needed to capture, we would go off and create data models with entity relational diagrams and all the dependencies between the data, the one-to-manys, many-to-manys, and where everything mapped. Again, perhaps over designing things that we didn't really know until folks actually started using it, whether any of this was going to be needed, right? Then it would enter a construction phase, where we would go off and be very, very diligent at building exactly what it is that we planned, right? It's but not knowing until the very end, right? When we submitted it to the end user, we would get some feedback and say, yeah, this is exactly what you asked us to build. Why are you mad at us? But that feedback would be a little bit too late, right? Because we have we have made so much effort at building very beautiful software, creating all the unit testing, all the integration testing. Changing anything at that point, right, would be extremely expensive. It would have been much nicer if we would have had some of that feedback early on, right, so that when we had not yet made so much more commitment to a particular architecture, to a particular implementation. Then obviously the deployment phase, and one of the issues was that oftentimes we, mentally or conceptually, we saw the deployment as the end of the project, right? And very little was thought on what happened after that piece of software was deployed. That oftentimes, more than half of whatever money you're ever going to spend on a particular software is going to be after it gets deployed. So any investment you could do early on, right, to make your life easier after it gets deployed, maintaining it and making any software updates, and just keeping it up, right? All that effort that comes after it gets deployed, it's a fair amount of a challenge that this waterfall didn't really take into account. So here's just a small comedic piece on saying, I'm going somewhere new that we've never seen. We're going to explore it, and there's, that's going to be exciting. How do you know you're not going to get lost? Well, says, well, no, we got maps and we got this huge plan, which is somewhat of an oxymoron. You have this huge plan to explore somewhere you've never been to. So it's trying to capture the idea that perhaps we are planning a little bit too much to visit a place we've never been. So, and you're making a lot of maps of somewhere you've never been to. So some of the issues that are usually associated with the waterfall model is that it assumes a little bit too much on that things just flow in a particular sequence, right? It's kind of what when we look at evolution and we see some of these graphics that mislead us into thinking that apes were walking on all fours and slowly they became upright human, right? So it's a little bit misleading. Reality is much more messier, right? Evolution took many different cul-de-sacs and turnarounds, and reality is not sequential, right? But us human beings, evolution has made us think in this sequential way, even though we have this highly parallel processor in our brains, right? It forces us to think in a very sequential way. Okay, so it's just an illusion. That we have this distortion field around us, that we have to accept it and try to understand it, that everything is actually very parallel. Things happen simultaneously. Also, again, it's very hard to early on to be able to state the requirements explicitly, and hopefully, and when one of the takeaways, hopefully, from you working with a real client is that Tuesday they'll come here and we'll have the interview, and over time we'll understand that it's actually very messy, right? Dealing with real clients and be able to understand that we're saying the same thing, right? Typically it helps that somebody tells you something, and then you after having it internalize it, maybe you repeat it to the other person to make sure that you're saying the same thing, right? That there's no misinterpretation. And that requirements, even if we do understood each other, it could be that as we move forward and as we know a little bit more, we discover that we were both wrong. Right, that our perception of reality was distorted, and that it's futile to try to predict things that cannot yet be cannot yet be described or explicitly. Again, very little thought on what would happen to the piece of software after it was deployed. Again, the customer kind of like came and then went for a while, and we didn't see the customer for months at a time, and they're not participating, and they're jittery on whether the progress is being made. We don't really have anything in between to demo for them, and we're in the midst of building it. So the newer techniques try to incorporate the client in the process, to make them real part of the entire process, so that any errors are caught early on, and we can reconsider. Right. So Barry Boehm, he's a historical figure. He's very well known at having studied and written a lot about development process in general. He managed quite a few large organizations, right? And he was very interested on what the processes were, and he was and he wrote a lot about it. One of the things that he's famous for saying is that it is in the requirements phase is where we make most of our mistakes, right? Of gathering those requirements, and the later we wait for fixing those requirements, it just becomes much more expensive, because as you move forward into a process, you commit. As you make decisions, imagine you had a decision space, and every time you make a decision, you're kind of pruning out all the possible scenarios, right? And you're always narrowing your possibilities as you move forward, so that it'll be very hard to maybe switch to another branch, right, of any of those other possibilities. So the earlier you can steer away from certain blunders, the less costly it will be. Right? So here's a curve that try to captures that idea that the later you try and fix something, just the costlier it will be. So we revisited some of these ideas and says, well, how can we fix this? How can we try and involve the user into the process? So let's stick to the same ideas of the same phases. We definitely have to communicate first, right? We have to plan. We need to create a model. We need to build it. We need to deploy it. So there's no way out of that, right? We need all those distinct phases, right? But could we perhaps commit to smaller deliverables, right? As opposed to committing to an entire huge piece of software, could we commit to something smaller, right? Perhaps the core functionality and demo, and design that, knowing that perhaps we have tons of other things we would like to do, right? But let's concern ourselves with a smaller, more attainable, something that it's less risky, or something that might be a little bit easier to predict, that is well understood. Let's focus on that first, and as we tackle new problems, we refactor. We accept the fact that we're going to be refactoring this source code often, and adapting it for the new features. It's a little bit what we used to do, right? This over here, where there was no structure, right? Could we marry? Can we take some of these same ideas, right? Of just a little bit of the hack, being able to hack software, which is the fun part, right? And grab some of this agility and put it into some formality that we know works, right? But has some issues. So can we adapt? Can we have a happy medium between chaos, right, and something that is very rigid, right? Can there be a happy medium? So some of the first efforts was, well, let's have increments. Let's commit to something smaller, right? And just deal with new increments and new releases instead of being yearly releases, can we do it maybe a half a year or maybe every quarter? And today, some of the newer, more modern processes look to create releases every day, right? Or create several releases a day, right? Extreme programming, kind of takes these ideas, these same notions of the software development cycle, the waterfall, and says these are all good. These are all good. So let's take each one of the themes and just take it to the extreme, right? What's the take a lot of these same idea and apply it to the extreme. So that's a little bit of what we're going to talk about when we get to extreme programming. So these are some of the first evolutionary step away from what is historically referred to as the waterfall. Let's take the same waterfall, but maybe shorten it a little bit, and let's commit to smaller deployments. Right. So we would focus on smaller increments. First, we would deal with a core set of features that were the main focus of the product. Right. There's tons and tons of things we would love to have, but there might not be the core functionality of the product. And it improved. It made it easier to allocate the various resources of time and money to the effort. So again, there would be a lot of prototyping where we would again the same 5 phases and then we would create a prototype that would be used to document and get some feedback from the end user, and then we would meet again, right? And then we would create a more expanded version of the prototype. And creating these prototypes entailed several ways of designing software, where you either designed it either at a particular level, depending on your specialty, where you might have front-end developers create a very thought-out user interface that could serve as a prototype, but it didn't have any guts, right, or any logic or any data behind it, where a lot of it would be just mocked, right, so that you could try out various things such as the navigation, right, such as the user experience, the user interface, and as this evolved over time and as it settled, it could then be used to design the later phases, right? It could use perhaps to elicit requirements from the end user, and as they became more and more defined, we could then go on and define the later layers. Or another technique would be that you would prototype it vertically, right, where you would not design the entire user interface, but maybe design one particular aspect of the user interface for the core functionality, and then maybe implement all the various layers for that particular feature, right? You would implement the user interface, the data model, the services, all the way down to the data layer, and for structure and the various data schemas that would hold the data. So usually development was a combination of both, right? Some horizontal prototyping and some vertical prototyping, especially if some aspects of the project were a little riskier, and we weren't sure of a new technique, of a new technology. We would prototype it to become more confident that particular technology. As I mentioned earlier, so there's horizontal prototyping where you would make use first of very inexpensive wireframes, right? Perhaps just draw it on a piece of paper, and enough that with enough fidelity that folks could use it, and maybe today you perhaps build it on PowerPoint or some designers are very good with Photoshop, and they quickly can put together a user interface with a lot of these templates, right? That they can drag and drop some of these wireframes and make it believable, right? That the user is actually clicking through them, and it looks almost like it's working. It's done, right? And it would be very inexpensive to make any changes at this point, right? Where they can easily just move things around. A good HTML CSS developer could whip it up, in HTML very easily, just by dragging and dropping some of these widgets, and build a working HTML prototype in no time, right? That even as part of the requirements gathering phase, we can put it in front of the stakeholders and gather some of their feedback, as early as possible, right? So that we don't commit to something that we're not going to build, right? And as we perhaps we can mock it up with some dummy data, so that the end users sees a realistic rendering of the software before we make the harder commitments of implementing the service layer, the data model, the schema, the database, all these other infrastructure that's very much more harder to change later on. So vertical prototyping. Once we agree, once we have done some horizontal prototyping and we agree on a particular aspect of the core functionality, we then start drilling down. What kind of database schema do we need? What kind of service layer do we need? Are we going to exchange data using XML or JSON or CSV, or are we going to use an object-oriented database or NoSQL database? So all those aspects, right? As you start deciding at a higher level and work your way towards the bottom layer. Right. So in the horizontal deals with the aspects of interacting with the user interface, right? Of handling all the user events as the user interacts with the piece of software, whereas vertical prototyping incrementally walks its way through the various technology stack down to the data layer. Now, oftentimes these prototypes, their main reason is for informing us about the feasibility of a particular solution, right? Not necessarily are they used for implementing the final product. Okay. Oftentimes these prototypes should be considered to be throwaway prototypes, right? That are good enough only to inform that this is, to inform us that yes, this particular user interface is what we want to do. This particular technique for posting the data and transferring it through the service layer and the data and the schema, whether it works, enough to inform us that indeed to validate some of the decisions, right? Once we make the decisions and when we are well informed and educated, we should resist trying to use the prototype in the final project, right? Oftentimes when we create prototypes, we make lots and lots of shortcuts, right? Lots of assumptions that are not valid when you're actually going to implement it, right? A lot of the decisions that you made just to display something real quick on a piece of software on a piece of user interface were only just that. It was just because you wanted to elicit some feedback. Yes.
Isn't this idea of creating a prototype and then throwing it away and making a real implementation kind of anti-agile, or how is it compatible?
Well, no. Again, the prototype would be simple even in the agile, right? The first thing you would display. Here's the HTML, what it would look like. Is this what you mean? and it would go back to the client, and the client says, no, that's not what I mean. And it would be again, you only commit to something that you can complete maybe in a sprint or two, right? Or in a week or 2 weeks in a sprint. So the prototype would take you maybe half a day to provide some little HTML. Here's the form. We're going to move this label over here. We're going to move that over there, and you just prototype it locally.
You're talking like Google, not like here's a prototype product.
No, that's the intent, right? The whole point is that you do something small, that you commit to smaller things that you're going to be able to solve in a sprint. Yeah, as opposed to a larger product where you say, okay, I'm going to go, for 6 months, a year, and you're not going to see me, and then I'll get feedback when this goes out, as opposed to let's include the user, right, in every decision as we go every week, right, or at the end, and then we demo what we did. I indeed moved the button up here. All the texts are supposed to have spaces between the slashes. And that might entail a whole week to do that, right? You need to create databases to update all those things that might be trivial from a user's point of view. I just want to add a space in between all the slashes. How hard could it be? Well, no, there's a whole data set that I need to update. There's a whole that only to display just this little piece of software. No. That makes sense. That you first implement it, perhaps even locally on your machine through a Skype. You say, "Is this what you mean? Is this what you want?" And then you go off and implement it. Now, could it be something that is too trivial that for a whole week? Probably. It might entail maybe a new form that you might be asking for 10 items, right, for a login page or for something else. And again, you would prototype it in HTML only, and then you would get some feedback. Yep. Mm-hmm. Yeah. No. These are all good things that we're borrowing from non-agile, and we're trying to adapt it into smaller chunks, right? Right. So we're ideally you would. Presumably, we're very, very small iterations. You just take small chunks that you can bite, and as you go, even as trivial as might be, you go through each one of the phases. You plan it, you model it. I want to be able to check this box because I want to make sure that you accepted the user agreement. Right, even that checkbox, right, it might entail a lot of work, right? I need a column to be able to store that. I'm going to store it as a bit. Then I'll need checkboxes, and I'll need the services to transfer that in JSON objects. I need to parse it in Java in the class data model. So it might entail just one little checkbox, right? It might entail modifying an entire stack across the architecture, so you plan, you do the data model, what needs to be added or changed, right? You test it whether indeed if you clicked on that checkbox, the database actually stored it, and then that feeds back into the next iteration, right? Now that I have a place to store the user agreement, well, then that means that I can go on to the next phase on whether I let you continue to the rest of the application or keep bugging you about accepting the user agreement, right? Which entails, again, another iteration of planning on how is it that I'm going to protect the rest of the application if you haven't yet accepted the user agreement, right? And so that feeds into that next iteration, the planning, the modeling, and whatnot. Okay. But at each step is trying to just grab a little more and a little more as you go forward in time. Right. So the spiral model, in the late 80s, again, tried to deal with small evolutionary releases. These were still fairly large, compared to today's releases, where the milestones were still fairly big, but the idea was to we see the beginnings of trying to minimize the commitments at each one of these iterations. Right. So in these new methodologies that we're starting to come up at the end of at the beginnings of the 90s and also in the late 90s was more or less the same idea, right? Which has survived through any of the processes, right? The communication, planning, modeling is part of all processes, but you would have this software increment that you could put into production that would have a minimum viable product, right? That we can that could be put into the market and start be using by actual users, right? That we can start using it and get some feedback to see if really this is what they wanted, right? Is this and we might find that they keep using this feature that we didn't think it was that important, that we didn't pay that much attention. They're using it a lot, whereas all this effort that we put in this other part of the product, nobody's using it, right? And all this money that we went towards some of the more sexier that we think were pretty cool features, nobody's using it, whereas some of them might be. So this feeds into the next iteration and says, ooh, maybe we found something interesting here, right? That we've learned from having made this available for the users. Again, the inception phase was to gather some of user requirements and come up with some preliminary use cases that are going to slowly going to evolve into more detailed use cases. So there might be very high level stories that we don't really know the details until we come back to it, maybe a little later, that we can start iterating over those use cases and make them a little more meatier, that might have a little more details. Right, so these might be very high level, somewhat vague use cases that a little later are going to become more specific. Architecture also, this will be a very high level architecture, considering more or less what the communication strategy is going to be, what the data layer is going to be, with the data centers and whatnot. But it's going to be hashed out as we know a little more, as we progress throughout the project. So in the next part, between the planning and the modeling, usually referred to as the elaboration phase, we revisit the use cases, and as we prototype and we know a little more on what we need to build, we'll need to revisit the use case and say, hey, you didn't consider these negative paths, right? All these error handling, right? What should happen when there's no data, or when there's too much data, right? What happens about all these edge cases? You don't know about the edge cases until you start building it. Okay, you might think you know some of them, but certainly it's until a software engineer actually starts building it and trying to represent it with a particular array and starts to try to iterate over something, and you iterate over something that is empty or iterate over something that is way too long, you start asking your questions. Says, wait a minute, maybe this is not the best approach, right? Can we revisit this, right? And then you realize that you had not considered pagination and filtering and searching and all these other aspects that were not part of the original design. And those new edge cases might feed into the architecture, right? And you might say, well, now that we know that we need to paginate and we need to filter and we need to search and all these things, well, then we need to be able to index all this information. We need to decide how do we decide what the data model is and what the primary keys are and what the compound keys are, and just revisit this because of we understand the problem a little better, right? Um, once you are in the middle of actually building it, right? You start to actually based on the architecture that you would agree, you go off and create the classes and schemas and services based on that architecture. Again, the more you start committing to a particular architecture and implementation, right, the harder it is to go back, right? So hopefully by this time you feel pretty confident on the particular requirements that you're working on, right? That they've gone through several prototyping phase, and that has gone through some feedback from the user, and it's fairly stable. The requirements are fairly stable, that you feel the confidence that of what is it that exactly that it is that you're building. Accepting that whatever you're building might change, right? As a requirement. So whatever you can do to modularize or generalize the implementation, if you need to come back tomorrow and refactor this, it allows you to do that. It also includes implementing tests that allows you to measure yourself, to pace yourself on whether you indeed have achieved whatever the goal of this piece of software was. That you can automatically push a button and it runs through tests verifying that you are slowly but surely getting towards your goal. Then there's the phase of transitioning and deploying it and making it available for users to actually start using it and giving you some feedback that later we can then grab that feedback and identify that there were some changes and new knowledge that's a kind of like a negative feedback loop, right? That allows us to readjust our efforts. Eventually goes out for deployment. We monitor it. We grab all sorts of statistical information as the user actually uses it in the field. That can then feed back into our understanding of the product, and then feed back into our process and make it better next time. Any feedback we get from the field, are reconsidered as it goes into a backlog that we can then consider as new requirements or changes into the requirements that feeds into the next iteration. And this iteration is meant to go, just endlessly. The product is never completed, right? You just little by little incrementally produce or maintain the piece of software. So this is oftentimes referred to as the unified process, which is a lot of it is still used today and informs some of the more modern techniques that borrow heavily from these ideas. It tries to take some of the best features of the conventional processes. It emphasizes design as opposed to implementation, and also uses a lot of the newer modeling techniques in the Unified Modeling Language, UML. We'll take a look at UML. I guess not Tuesday. Oh, wait, Tuesday we were going to do UX, but we're going to have the client, so we haven't done UX. We would be behind. Huh, okay. All right, we'll deal with that. So the general feeling is that some of these processes are harder to steer, right? They're very, very strong, very heavy, but hard to steer. Some of them, the newer ones, presumably, we'd like to think that we are nimble and we can easily adapt to changes. So agile, it's more a change of attitude that tries to deal with the changes in our industry changes in the attitudes of our users that come coming from a history of having dumb terminals to having personal computers to having a computer in their pocket, right? So this evolution in our end users has drastically fed into the way we develop software. Okay, so the advent of the internet and the ubiquitous computing machines and the different also in the evolution in our own field in object-oriented technology and service-oriented architectures and component technology. So all these changes has made us rethink our attitude towards software engineering. Going from being very adverse to change to welcoming change, right? So in previous processes, folks were very adamant or did not welcome change. Instead, because change just screwed everything up, right? I had all these tests, I have all this process to document all this, and I've written all this. I just have to throw it away and start all over again, right? So how can we adapt our way into welcoming change as opposed to being adverse towards it? And also, it focuses our effort at not so much as a process, but more becoming a more collaborative amongst our developers, right? Instead of us being in our own cubicles, perhaps let's all just scram in one room with a big table and just have conversations back and forth real quick, so that we can all come up with a solution. Kind of like borrowing from hackathons, right, where we can all go and try to solve something by the end of the day, right? Focusing more on just getting software to be working software, that the software itself documents itself, that it's self-documenting, that it's understandable, that you should be able to just read it, and it shouldn't even need comments, right? Some folks might say, "Oh, you had no comments." Well, it should be understandable. That might not need any comments, right? That the function names are trivial. That the methods are short enough to understand just by glancing at them, and so it'd be useful for other folks, reusable for other folks. So some folks might look at this and say, well, isn't this going back to just chaos or hacking? Those days where everything goes, right? And is it just programmer heaven, right? Where we're just in one big hackathon all the time. And well, that's not the intent. Although certainly we'd like to bring back some of that that romantic feeling of coding for coding's sake, because we all enjoy it. But also, how can we create some form of feeling of normalcy of process, even though we would like to be more agile and more and be able to have the more liberty on what to work on. It's really agile is borrows from quite a bit of other ideas. Many of them that have been around for forever. Some of them that are fairly newer, and tries to. So it doesn't force you to any one process. It's just perhaps a change in attitude, right? On how you your attitude towards software development, right? That don't assume that things are going to be not going to change. Things are going to change. You just have to accept it, right? And just plan your life, your software process to be able to respond to that. You still have the 5 general steps of communication, planning, modeling, construction, deployment. But we're going to try again to make them even smaller, right? Where you're going to have very, very short iterations where it might be just adding a comma here and moving a button there, right? That I can certainly let you know that by the end of the day I will have moved this button from the top to the bottom, okay? Or that I can with confidence tell you that I will have created this this form by in 2 days time, right? So that once we have that kind of confidence, we can feel accomplished at the end of the week that we have indeed deployed and delivered value for our software. So this kind of try to illustrates the notion of flattening these various phases with the waterfall, but have been very extensive. Iterative made the first effort at flattening a little bit and shortening, and Agile is saying, well, let's go even further. Let's try and grab those same 4 or 5 phases, but bringing it even thinner. So some of the aspects of comparing the plan-driven legacy processes compared to Agile, you're going to be working on low critical things, right? Again, like moving a button. Whereas plan-driven, you're probably going to work on something that has huge impact at the end of a year, where as opposed to Agile is going to have something very low impact at the end of the day, right, or at the end of the week. Since you're going to be accepting the fact that things are going to change, and you're going to have to refactor things, and folks are going to be changing their minds and requirements, there's going to be a lot of modification and movement of source code around, and you're going to need a lot of very senior developers that understand what the impacts are. That wait a minute, you want to remove this checkbox from here? If I'm adding this checkbox, that means I need a data model of the client. I need the UI. I need to style it. I need to create the JSON model, all the controllers, the services, and all the way to the schema. So that one checkbox is really I already know I'm senior enough that I need all the stack, right? And I already know what I need to do. Whereas a junior might not be understand the impacts of changes so quickly. Requirements changes often in Agile, as opposed to plan-driven is rarely. Number of developers, you're talking about a small group, very tight, knit, closed group that has worked together for a while, perhaps, that works very well together, as opposed to plan-driven, where you're in your team and you're oftentimes interacting with folks that you don't know. Your emails come and go, and you have this, and you feel that you have all the time in the world since you have a year to complete this, as opposed to Agile. You say, well, I need to have this done by the end of the day, right? So it's the culture in Agile thrives on chaos. They're okay with if in this week's demo, if the client wants that button, they ask them to remove it. They want it back there since last week. We just laugh it off. That's okay. We have source control. We can go back and go back and to source control and retrieve whatever we had previously there. Whereas plan-driven looks for they demand order. So why? Well, because it's very hard for us to predict the future. So Agile tries not to predict the future, right? It tries to focus on the now. Let's deal with this. Let's resolve this. It takes a very greedy kind of approach, right? Oftentimes, when we're trying to build something or optimize something, we try to optimize the whole thing. Try to take a very very wide look at something. Because we think that if we would make a decision, a very important decision on something that is very local, we don't know if that's going to take us towards the best optimal outcome, right? So typically the question of whether to use a greedy algorithm. How do you know that a greedy decision today is actually going to be the best optimal solution, a global solution, right? How do you know? If you optimize something and you go and reach a plateau or reach a maximum, how do you know that any other step is not just going to make it worse, right? And perhaps the best solution is way out there and so far that you can't see it, right? And you think you're at the best of your game, right? So anyway. again, it's very, very hard to predict. So Agile tries to be malleable and just focus on the immediacy of what is going to work. Do we? Well, no, I think we were going to skip over some of these. Right. So some of these ideas that that Agile borrows from is extreme programming. If we try to compare this with some of the original development processes that we looked at earlier, it's very similar to the code until the user is satisfied kind of thing, right? But the difference is that in extreme programming they rely a lot on creating lots of tests, right? That allow the developer to know how far they are in their progress, right? That the test always tells them that hey, you're not there yet, right? Because these tests are failing, and so a lot of the front effort in extreme programming is defining good tests, right? That can measure, right, your particular progress as you're coding. A lot of these the planning sessions are the results. You result in lots of post-it notes that very briefly capture the particular story of a particular feature that the software or particular behavior that the software needs to fulfill, and then you design it again as to keep it as simple as possible. Try not to over design. If not trying to predict that you're going to need all these other fields later on. Let's focus on the fields that I need to model this particular aspect or behavior of the software. You code it, always making sure that you can test it and see how far you've gone to achieve the particular feature, and understanding that you're going to be continuously refactoring this. You're going to come back to this, right? And you're going to make improvements, incremental improvements to the software. It also makes a lot of use of pair programming, where we don't sit independently in cubicles, but in these large open spaces where we all come and we all sit at the same table, right? We're next to each other, and I can review your code, you can review mine, and everybody takes ownership of that piece of software before committing it and merging it into a master branch. Lots of tests that measure your progress on and how far are you to completing a particular behavior or particular functionality. And as you iterate quickly, perhaps on the same day, you might iterate various times. You work towards a working prototype. They look to have multiple deliverables per day. It's some of these might feel that it's madness. It somewhat has some of the reminiscence of way back when in the some of the techniques that were in vogue more than half a century ago, right? We're kind of borrowing some of these same ideas that were effective back then. How different is it? So Scrum is a part of is one of the strategies, not strategy, some of the tactical aspects of the strategies of these development process. Scrum allows you to is a mechanism for managing projects and development application development that allows everyone to come and describe what they've been working on, to identify if anyone is blocked by any other folks that we could perhaps throw some folks towards that effort, and it's all about maintaining communication and understanding where everybody is at, right? And that and if we need help, we could shift some of the team members to help out and unblock somebody, right, so that they can continue to improve the overall efficiency of the team. There's a lot of there's a lot of interactivity. There's a lot of communication amongst the team, and and it splits up the development process into various what are referred to as sprints. That could be a week or 2 weeks long. Some of them could be as long as 3 weeks. And during that sprint, we have meetings every day where for 15, 20 minutes, folks just stand up and describe the things that have been working on for the last day or so. What is the plan for the next day, and anything that is blocking them, and try to steer the efforts of the team towards unblocking or making sure that the overall efficiency of the team stays on par. And the idea is that we try to have incremental releases every sprint. At the end of the sprint, we demo our results to perhaps a user, right, that is representative of the business, that can give us feedback and let us know how we're doing overall. Here's some of the terminology. We keep track either with some software such as Jira or GitHub of all the different tasks that are still to be completed. Sometimes referred to as the backlog. All the things that have not yet been assigned. That at the end of the sprint, towards the end of the sprint, the business, the project manager and the business analyst and the client agree that what are the new features, right, that are going to be worked on, that were in the backlog. We're going to put them in the sprint. What's going to be done in the next sprint, and then folks go out and for the next couple of weeks, maybe a week or two, or maybe even a whole month, they work on these features. And then give they do some of the design effort, some of the architecture, some of the planning, some of the implementation, and then QA and testing towards the end, and then demo the results at the end of the sprint. And then we'll go back and just do it all over again in the next sprint. In the Scrum meetings, we have 15, 20 minutes where deliberately we all stand up so that nobody's comfortable. As just to babble and keep talking. If anybody is taking way too much time, we table that and says, okay, we'll take that offline and create perhaps a follow-up meeting that can be done afterwards to deal with a particular issue. And then at the end, we give demos to the customer and get feedback from the customer. All right, that's SDLC.